again to my YouTube channel. Today we want to continue with our introduction to practical physics. Okay, I'm Nwachukwu Daniel. Now, there are some terms you'll be hearing in practical physics, such as maximum error and standard error. When you have a uniform instrument, such as ruler, for instance, and they say, this is your centimeter rule, which you know that here is 0, here is 1, here is 2, here is 3, and so on. And they say, what is the maximum error in this instrument? Maximum error in any uniform instrument, such as meter rule, micrometer screw gauge, vernier caliper, maximum error of it simply means the reading accuracy of that instrument. Since it is a uniform instrument, the reading accuracy of that instrument is the maximum error. What do we mean? You know, here we have 10 gaps. 1, 2, 3, 4, 5, 6, 7, 8, 9. Before you have your 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, because we have 10 spaces, before we have this 1, and have 2, and have 3, the maximum error simply means 1 minus 0. 1 minus 0, it will give you 1. All over, how many spaces do we have? How many small lines do we have? 10. 1 over 10 equal to 0.1. If the unit of this is centimeter rule, it will be 0.1 centimeter. This means that it is the reading accuracy of this instrument, and also it's the maximum error of this instrument. In a uniform instrument or uniform measuring instrument, such as vernier caliper, micrometer screw gauge, and the ruler, the implication is that maximum error of it is equal to standard error of it. Every uniform instrument have equal error, that is equal standard error and maximum error. Maximum error of a uniform instrument and standard error of a uniform instrument are equal, and they are also equal to their reading accuracy. This is for standard, this is for uniform measuring instruments. Now, when they write the error of that instrument, they must specify whether it's standard error or maximum error. Then they must also specify here that this is standard error or maximum error. But if they did not specify, you can say that this is the standard error, or you can also call it maximum error. This is standard error or maximum error if they did not specify. But as far as that instrument is a uniform measuring instrument, such as ruler, micrometer screw gauge, vernier caliper, tape, and others, the maximum error is automatically equal to the standard error. That is the point we want to take note of. Then, and is equal to the reading accuracy, only for uniform measuring instruments. Then, in the question we have, they say we should get the value of G. Write down the formula T equal to 2 pi root L over G. Say that, bring this inside, have T equal to square root of 4 pi square L over G. Then, carry this square root to the other side, you have T square equals to 4 pi square L over G. Now bring this T square down, make G subject of formula. G will be equal to 4 pi square L over T square. That means when you plot a graph of M against T square, your slope will be equal to change in L all over change in T square. So automatically this will give you your slope. So the slope of this times this will give you your G. How do you get it? G equals to we write 4 pi square. When we write 4 pi square, then you say times what is your L? 100 all over what is your T? 2.01 all squared, because our T is given to us. Then you open your calculator and you put this parameter there. You say 4 pi square that will be times 100 divided by 2.01 squared. That will be giving us 977.42. Then you now say, what is the unit of the L? cm. What is the unit of the T? Second square. This value we have here is equivalent to 9.774 meter per second square. When you divide this by 100, you get it by meter per second square. Then the question now is find the standard error in G. For you to get the standard error in G, say standard error in G equals to G times N SL all over L all squared plus minus 2 times ST all over plus M times ST all over T all squared. Now, how do we know our N and our M? See what we do. We go back to this question. This is an ordinary number. Forget about it. It's a constant. Ordinary number is a constant. Now, what you do is that as you forget about this, you pick N over T squared. You say from G equal to N over T squared, it implies that G equal to N raised to power 1 T raised to power minus 2. Because if power of 2 comes, so it becomes raised to power minus 2. Now, this will be your N for your M, and this will be your M. That is N and your M. N equal to 1, M equal to minus 2. That is, the power of T is M, the power of L is your N. You put it here. You say, what is your G? 977.42 times square root of, we have 1 times, what is our SL? 0.1 all over 100 all squared plus minus 2 times 0.01 all over 2.01 all squared. So, if you put it in your calculator, you will be having 977.42 times square root of 0.000001 plus 0.000099. So when you multiply the answer you got here to the answer you got here, you will be having, continuing from here, 977.42 times 0.01. This one will give you 0.01 when you sort it out. So that will be giving us 9.77 cm per second squared. So our error in G is 9.77 cm. Therefore, our G is equal to 977.42 cm per second square, whereas our error in G is equal to 9.77 cm per second square. That is how to get it. So you have to rearrange this to be in this form so that you get the value of your N and the value of your M. Then put it in this formula. Once you put it in this formula, multiply it to your G. When you multiply it to your G, then that is your error in G. Okay? So thanks for watching the video. Please don't forget to subscribe to my YouTube channel and like the video as well. See you next time.